Hi again. Okay, before we start talking about our changing climate, such as climate change, we need to know what the world was like when humans were getting our act together after the last glacial cycle around 11,000 years ago. Glacial cycles, according to latest scientific understanding, are caused by periodic dimming of the sun's intensity, coupled with changes in the Earth's orbit. Anyway, not really relevant yet. At the start of the Holocene, global temperatures were similar to that at the start of the Industrial Revolution, and carbon dioxide was around 300 ppm, or parts per million. The poles had plenty of ice during the summers and winters. The tropical rainforests were lush and dense with a teeming diversity of life. The great forests of North America and Russia were magnificent and healthy. The oceans had abundant fish, huge benthic mammals, plankton and crustaceans of all levels of the food chain. The lush greenery was drawing down the correct amounts of carbon dioxide, as was the oceans, and that carbon became the hard covering or exoskeletons of plankton, seashells, the bones of marine vertebrates, marine animals with spines. As they died, they sank to the bottom of the ocean, taking with them all the carbon which, over millions of years, would transform into sedimentary rock and oil and methane gas or frozen methane. The rays of the sun would warm the atmosphere, giving energy to all life. The weathering process on rock, especially sedimentary rock that was once a lake bed, will then turn by tectonic forces onto its side to form mountains and valleys, would release the stored carbon and thus balance the ratios of greenhouse gases. Forests and grassy plains would periodically burn due to, say, a lightning strike, releasing the carbon in CO2 form again into the air. Animals and plants that died on land would give up some of its stored carbon to the air, and the rest returned into the ground. The flora on Earth, on land and floating on the seas and lakes, would exhale carbon dioxide at night and take in oxygen, and during the day do the reverse, take CO2 out of the air to contribute to the growing process and breathe out oxygen. The atmosphere was just thin enough to allow the sun's energy that wasn't needed by the Earth's biological processes to escape back into space, but thick enough to keep some heat near the surface. Volcanoes did many things, such as spewing out huge amounts of carbon particles, CO2 and methane and sulfur dioxide. The carbon particles, CO2 and methane, would trap more of the sun's heat, but the sulfur dioxide would dim the sun's light energy. Still, volcanoes are generally considered to have a net cooling effect on the Earth's surface. So in a nutshell, total energy in from the sun equals energy stored in the atmosphere and the Earth's surface plus the Earth's energy that escapes back into space. And that's how it was for at least the last few millions of years. For that's how back really accurate measurements of gases, radioactive isotopes and recently fossilized evidence really extends. There were periodic fluctuations during this time, such as ice ages and Milankovitch cycles, caused by the Earth's rotation around the Sun, lasting around 100,000 years, and smaller cycles caused by slight changes of the angle of the Earth's tilt, lasting around 41,000 years. All these cycles do not happen overnight, but over thousands of years, and usually only affect one hemisphere more than the other. Even the end Cretaceous-Paleogene Great Extinction event 66 million years ago took at least 10,000 years to take the final toll. More of a combined inconvenience or a benefit to life forms, depending on whether you like the hot or the cold, rather than a mass extinction cause, like the reshuffling of the deck of life. The most logical way of determining if current climate change is human-caused or anthropogenic or natural is to compare all the knowledge and data we have from past natural planetary cycles and terrestrial and atmospheric cycles to the data we have since the Industrial Revolution. Therefore, you will see that about the only standout difference is the amount of CO2 in the atmosphere. 270 ppm to now 411 ppm is a massive change in only 200 odd years. So now you are aware of a stable climatic system that humans and almost all other animals and plants could prosper without the threat of major upheavals in temperature or rainfall, or regular drought conditions. In the next video, video 3, we will cover the gases and chemicals involved in maintaining life on this planet, and the ones that are now out of balance. See you there.